Chapter 5, Polynomials and Exponents. Here we will focus on exponents. Basic rules in working with exponents. When we're given a number raised to the mth power, a is the base and m is called the exponent. When we multiply that with a to the n, that is equal to the base a raised to the power of the sum of the exponents m plus n. When we have a to the m divided by a to the n, that's equal to the base a raised to the exponents m minus n. Here's problem 79 on page 368. We're given 1 over 6 to the negative 2. To clean up the negative 2 in the denominator as the exponent for the base 6, we'll multiply the top and bottom by 6 squared. And we'll see why. Because when we use the rule, the first one, when you have the same base and you add the exponents, when you multiply them, you'll get in the numerator 6 squared, and in the denominator, the base 6 with the exponents added, negative 2 plus 2. So when you take 6 raised to the power negative 2 plus 2, that is 6 to the 0. Any number raised to the 0th power is always equal to 1, which makes our denominator 1. Therefore, our solution is just 6 squared in the numerator, which is 36. Let's have a look at a little closer what's happening here. Any number raised by a negative exponent is really the reciprocal, but with a positive exponent. In other words, if you have a to the negative m in the numerator, that's the same as saying 1 over a to the positive m, where a to the m now is in the denominator. Or if you have 1 divided by a to the negative m, which is the form we saw on problem 79, that's the same as having the denominator of a to the negative m as the numerator now, but with a positive exponent, a to the m. Problem 81 on page 368. We have 3 to the negative 1 times 2 squared, both terms raised to the negative 2. Let's recall our basic rules with exponents from the previous slide. And know that when we have a negative exponent, it's the same as the reciprocal, but with a positive exponent. So this can be rewritten as, since it's in the numerator, into the denominator, but with a positive 2 instead of a negative 2. When we expand this out, because when we square a number, it's just multiplying that number to itself, we will have 1 over the whole thing, 3 to the negative 1 times 2 squared times itself, 3 to the negative 1 times 2 squared. Let us combine our bases first with 3, so we will have 1 over 3 will be raised to the power negative 1 and negative 1. 2 will be raised to the power of 2 plus 2. Simplifying further, it's going then to be 1 over negative 1 and negative 1 is negative 2. So 3 will be raised to the negative 2, and base 2 will be raised to the 2 plus 2 is 4. So it's 2 to the 4th. To clean up that 3 to the negative 2 exponent, we know that that's the reciprocal with a positive exponent. If it's in the denominator, it will now be in the numerator, and 2 to the 4th will stay in the denominator. Finally, our last line will read 3 squared is 9, and 2 to the 4th is 16. Here's another thing to note, that when you raise a term that already has an exponent, it's the same as multiplying the exponents. So let's add this to our basic rules with working with exponents. We know that when we have a base a raised to the mth power, both base and exponent raised to another exponent, it's the same as multiplying the exponents together. Let's see if we can do the same problem using this. When we have the original 3 to the negative 1 times 2 to the 2 squared, both raised to the negative 2, we can multiply the exponents by the outermost exponents of negative 2. The base 3 raised to the negative 1 times negative 2 is positive 2, so it'll be 3 positive 2 squared. And then the 2 raised to the 2 times the negative 2 is the negative 4, so we'll have 2 to the negative 4. To clean up the negative 4 exponent of the base 2, we can rewrite this. 3 squareds can stay in the numerator, but 2 to the negative 4 being in the numerator will now be in the denominator. And that's the same solution as above. Problem 89 on page 368. We have x times y, quantity, raised to the negative 2, times x to the negative 2 times y, quantity, raised to the negative 1. We can do the power raised to the power rule, so that the first term will be x to the negative 2, y to the negative 2. The second term will be x to the negative 2 times the outer exponent of negative 1, then y raised to the negative 1. Let's combine our bases starting with x. The first one we see is x to the negative 2, and the second is x raised to the negative 2 times negative 1, which now becomes positive 2. For the next base, y, we have y to the negative 2, and the second y is to the negative 1. We'll combine further using the first rule of working with exponents with the same bases, where you add the exponents. So for the x, it's x to the negative 2 plus 2, and the y is negative 2 minus 1, which is y to the negative 3. So we saw that x to the 0 is going to be 1, and to clean up the y to the negative 3, we'll bring that to the denominator and get 1 over y cubed. Problem 95 on 368. 3m cubed times n, all raised to the negative 2, over 2m squared times n to the negative 3, all raised to the power of 3. We'll expand it by using the power to the power rule, so that the outer power, negative 2, will be applied to all the terms within the quantity. So we have 3 to the negative 2, m to the third times negative 2, and n raised to the negative 2 in the numerator. The denominator will be 2 cubed m raised to the power 2 times 3, n to the negative 3 times 3. Or cleaning up a little bit, combining our m's and n's, we'll have 3 to the negative 2, m to the minus 6, because 3 times negative 2 is negative 6, and so on for the numerator. And then for the denominator, we'll continue to keep our 2 cubed, m. Again, 2 times 3 is m to the 6, and negative 3 times 3 is negative 9, so n will be to the negative 9. To, again, clean up the negative exponents, we know that they can be switched around. If they're on the top, then they belong in the bottom, and vice versa. So we'll finally have the 3 will be the raised to the second power will be the denominator, m to the negative 6 will be in the denominator, n to the negative 2 will be in the denominator. The 2 cubed stays where it is, the m to the 6 stays where it is, but we know n to the negative 9 can be rewritten as n to the positive 9 is a numerator. Now we can combine the bases. If you have a similar base, the exponent can be either added or subtracted depending on whether it's multiplication or division. So for n, we have a 9 in the numerator and a 2 in the denominator, so we'll subtract their exponents. We can resolve 3 squared, which is 9, and 2 cubed, which is 8. Then we can combine the bases m, which have exponents 6 and 6, so we can add them. And then finally, to do the arithmetic, we'll have on the numerator n to the 7th, and on the denominator we'll have 72 m to the 12th.